Okay, class, we're about to start section 310 and 311. For 310, we have selected to do the problems 5 and 7, and for 311, we selected to do the problems 7 and 9. So with that being said, problem number 5 from 310 starts on page 359. And the problem goes like this. It says the formula R equals 80.4 minus 11 natural log x is used to approximate the minimum required ventilation rate, R, as a function of the airspace per child in a public school classroom. The rate R is measured in cubic feet per minute and x is measured in cubic feet. It says sketch a graph of the rate function for x is greater than or equal to 100, but also x is less than or equal to 1500. Now remember, they want us to sketch a graph. That means that it doesn't have to be pinpoint accurate. It just has to resemble that. So that is why we're going to use Desmos. So what I would suggest that we do is put this equation in, but make ry, and we can leave x. So we would have y is equal to 80.4 minus 11, and then we would need to get the natural log. So we'll hit the actually we're supposed to hit the function, and then miscellaneous, and then natural log, and then x. Now if you notice here, we do have a graph here. But now we're going to do a table. So we hit the wheel, hit the table. Now remember how it was told to us that we wanted to graph between 100 and 1500 for x. So remember, the lowest x could be is 100 and the highest it could be is 1500. Now if you notice here, let me expand this out. You notice here on this graph, we have these points. Now, I did this earlier because this was a question of one of your classmates. What you were supposed to do that would make this graph visible was first hit this wrench and then go to the x value. Now remember, the x value is in between that 100 to 1500. So whatever you have here for x, you could just start it off. I would go 10 below it and put 90. And then as far as the 1500, I'll go 10 above and make it 1510. Now we can scroll in and we can see the graph quite well here. Now, what I did when I put in the 100 and the 1500, you could click on those points and you see this is where 100 would start, and this is where 1500, well, about 1500 would be here. Because with 1500, it's going to go below the x-axis for the y. So you would start here. It would not touch the y-axis, and it will go here and it go across the x-axis, but you would have to end the points. So it wouldn't be an arrowhead. You have this point to this point here. Does everyone follow that? And when I say this point here, I'm talking about the 1500. So it'd be 1500. So that's how your points would be graphed. Okay, now that took care of 5A, basically using the Desmos graph. Now we do 5B. It says determine the required ventilation rate if the airspace per child is 300 cubic feet. Now our X value is what the cubic feet is. So all we would have to do is take this formula and substitute in 300 for X. So we could put that right in our calculator. We can either put it in the calculator, like type it in as is, 80.4 minus 11, natural log 300, or we could go right here to this table, and for the X value, just put 300 in, and it gives us our answer. We'll round to 2 decimal places. It'll be approximately, R will be approximately 17.66 cubic feet per minute. Okay, next, we'll do problem number 7. Number 7 was a requested problem. So we have 7A. Now we are given this formula here. I'm going to write the formula off to the side, which is T equals the natural log of M all over N times the natural log of 1 plus R over N. Okay, now it says here, the following formula can be used to determine the time, T, it takes for an investment to double or triple, or so forth in value. So we have that formula, where M represents the number of times the investment is to grow in value. So M equals 2 means that it doubles. M equals 3 means that it triples. Okay, now it says R is the annual interest rate expressed as a decimal. N is the number of corresponding compounding periods per year. It says how many years will it take an investment to double? So now, since we know that it says double, we know that M is equal to 2. It says, and how many years will it take an investment to double if you are receiving an annual rate of 5.5%? So R is equal to 0.055. And then it says compounded quarterly. Now, quarterly we know means 4. So that means that N is equal to 4. So now we have all of our information that we need. So we're going to substitute these values into this equation. So we had T is equal to the natural log of 2 all over N is 4 times the natural log of 1 plus R is 0.055 all over N, which is 4. So we will put this in our calculator. So first thing, we'll go to functions. We'll go to natural log. And then I'm going to do the division. Oh, no, that's not. Hold on. I'm going to have to click behind it so we could do the division. And then now I will put in the 2, close my parenthesis. I guess so. All right. And then in our denominator, we have 4, and then a natural log. And then we will have 1 plus 0.055 divided by 4. So we will have 12.689, approximately 12.689, and that's years. All right. Now, we move on. I think I need to make this just a wee bit bigger, or maybe, yeah, I think that'll be better. Yes, okay. See just about the whole thing. Okay, so now that's 7A. Now we go to 7B. 7B, how many years will it take the investment in Part A to triple in value? So basically, we will have the same exact problem, except for instead of the natural log of 2, it'll be the natural log of 3. So everything else remains the same, except it'll be natural log 3. And what's nice about Desmos is we could just go here, take the 2 out and put 3 in its place. And then now we have our answer. So it'll be approximately 20.11 years. Now we go here to C. It says, suppose the interest on the investment in part A was compounded monthly. So that means that N is equal to 12. How long will it take the value to double? Now remember, it's part A. So if we look back up at part A, the only thing that's going to change is that these 4s will become 12. Everything else will remain the same. So you have natural log, well, T is equal to the natural log of 2. So 12 times the natural log of 1 plus 0.055 divided by 12. So we'll go right here to Desmos, change the 4s to 12s. And now, maybe I must have left something out. Let me see, 12. Oh, I forgot to change that 3 back to a 2. Okay. So it'll be approximately 12.632 years. So if you notice here, when it was only compounded 4 times a year, it took a little over 12 and a half years. Compounded every month of the year, it was just slightly lower. It's not that much difference. So any questions on problems 5 or 7 from 310? Okay. Now we move on to 311. And we're going to go to page 368. Now I'm going to do problems 7 and 9. Problems 7 and 9. So we're going to do page 368 and also page 369. Okay, so now, starting with problem 7, it says write each of the following as the logarithm of a single expression with coefficient 1. So we would have 7a. So we have 2 log base 2 of 7 plus log base 2 of 5. All right, so with that being said, they want us to make this into a single logarithm with a coefficient of positive 1. All right, so you need to know some of the properties of logarithms if you do not know them. Now, the properties, all of the properties are listed at the bottom of page 366 to the top of page 367 under the summary. But I'm going to go through this. Okay, first of all, when you have a number multiplied to a log, that number used to be the exponent of the argument of that log. Now remember, with the log, let's take a look here. We have log b of a is equal to c. This is your typical log. The a is the argument, which in this case here would be the 7 and also the 5. The b is the base. The base here is 2 for both. And then the c is the exponent. And the exponent, if you notice here, that's what we're trying to get to. Well, when we solve the problem. All right, so this right here, when you have a number multiplied to a log, it becomes the exponent of the argument. So it'll be log base 2 of 7 squared plus log base 2 of 5. Since there's no number multiplying to this log, you do not make it the exponent of the argument. So this becomes log base 2 of 49 plus log base 2 of 5. Now, whenever you have logs that have the same base and they're added together, nothing is multiplied to them or anything like that, and they're added together, you can combine them to one log with the same base, but the arguments, you will multiply the arguments together. So it'd be 49 times 5. Now, when you multiply these together, you get log base 2 of 245. Now, you don't necessarily have to have that in a parenthesis, but I just do it out of habit. All right. So let's take a look here at 7b. We have 1/4 log x cubed minus 1/4 log z to the 5th. Okay, just like in a previous problem, the value multiplied to the log is its exponent. So we have log x to the 3rd power, and then that would be taken to the 1/4 power, minus log z to the 5th power, and that would be taken to the 1/4 power. All right, now, again, I told you all before, well, first, let's do this. Since we have a power to a power, we can multiply those exponents. So this would be x to the 3/4 power minus log, and it'll be z to the 5/4 power. All right. So now, remember in the previous problem, we had logs with the same base. We added them together. That gave us multiplication. We had logs with the same base in the subtraction. So that means that that would give us division, because that's the opposite. Subtraction is the opposite of addition, and division is the opposite of multiplication. So it'd be log x to the 3/4 power divided by log z to the 5/4 power. Okay, now we have both of these. Now what we could do is this here. Since we're dividing, we know that x and z are not like terms. But if you notice here with their exponent, both of these are taken to the 4th power. So this is the same as taking the log of the 4th root of x to the 3rd power all over log of the 4th root of x to the 5th power. Now, because they have the same base and both of these logs have the same radical, we can make this into one log, and we'll take this to the 4th root of x to the 3rd over x to the 5th. I mean z. I'm sorry, that's supposed to be z. I'm going to change the variable. Let me rewrite that. It's supposed to be log the 4th root of x to the 3rd over z to the 5th. That would be your final answer. Now that's 7b. Now we move on to 7c. 7c, we have 2 natural log 10 minus 3 natural log 5 plus 4 natural log z. So again, all of these are exponents. So we had natural log 10 to the 2nd minus natural log 5 to the 3rd plus natural log z to the 4th. All right. So now we know that this would end up being natural log 100 minus natural log 125 plus the natural log of z to the 4th. Now remember, when we have the same base, which we notice all of these have the same base, the first thing we know here is, because we have subtraction first, that this would be division. So we had a natural log of 100 divided by 125. And then it'll be times z to the 4th. Because remember, we're combining all of these to one natural log problem. So this would be natural log times, we could put a 1 under the z to the fourth. It'd be 100 z to the fourth all over 125. Now 100 and 125 both has 25 in common. Or you could use your Desmos calculator. We could type in 100 divided by 125, and it gives us 0.8. Well, we click here, and it gives us the fraction 4/5. So this would be the natural log of 4z to the fourth all over 5. And that is your final answer. Now, there is one thing that I need to go back with 7b. The answer that we have for 7b is correct, but I made a slight little error here that I want to correct, and you all could put this in your notes. Like up here, that was fine. But when we got here is where I made an error. So I want to correct that error now. So the error was, instead of having log x to the 3/4 over log z to the 5/4, I should have just had one big log, and then it would have been x to the 3/4 over x to the 5/4. Because remember, when we changed this from subtraction, it was supposed to become one log, not two separate logs like I have here. So basically, this problem here should have went to this step here, which would have led us to this step here. So this is the step we should have. But what I may do at the end of the video, I think what I'm going to do, I'm just going to redo all of 7b so it'll be nice and clean. But you basically have the answer. All you would have to do is just change that one part. Okay, now we go here to 7d. 7d, we have log base 5 of x plus 2 plus log base 5 x plus 1 minus 2 log base 5 of x plus 3. All right, that's a lot of log writing there. Okay, so we will have log base 5 of x plus 2 plus log base 5 of x plus 1 minus log base 5 of x plus 3 squared. All right. So now we can start combining these. This right here would give us log base 5. And we know we're going to multiply these two. So it'd be x plus 2 times x plus 1. That would be in our numerator. Our denominator would be x plus 3 parentheses squared. All right. Now we multiply. X times x we know is x squared. X times 1 is x. 2 times x is 2x. And 2 times 1 is 2. That took care of our numerator. We do have to combine like terms, but that's fine. Now this x plus 3 parentheses squared, I'm going to go off to the side. And you have to do x plus 3 times x plus 3. So that would give us x squared plus 3x plus 3x plus 9. So now we have log base 5 of x squared plus 3x plus 2 all over x squared plus 6x plus 9. All right, now that took care of 7d. Now we go here to As a matter of fact, let me redo 7b, and then we will go to 9. So 7b, I'm just going to write out what I had previously. And I'm not going to actually go over everything here. We know we changed that to an exponent. Okay. Then we had log of x to the 3/4 power minus log of z to the 5/4 power. And then here's the next step that should have been the difference. When we combine these for division, it should have been log parenthesis x to the 3/4 power over x to the 5/4 power. Oh, I don't know why I keep changing that to x. That should be z to the 5/4. Okay, so now when we look at this problem here, both of them have a denominator of 4, which means that both of them will have the 4th root. So we would take the 4th root of the parenthesis. What would be left was x cubed over z to the 5th, which is the same answer that we got before, but this was actually the proper way of doing it. Now, we go here to problem number 9, 9a. Now, we're using this, I won't say tactic, but this way of doing logarithms that basically without a graphing calculator or Desmos, you still would be able to do this. This is the change of base form. So if you had a calculator where you could not change the base of your log, this is what you would need to do. And it also works for the natural log as well. To do the change of base formula, you would change these to have a base of 10. So this would become log of 5. So the argument would still be the argument, but now it has base 10. And then it'd be divided by log of 7. So instead of 7 being a base, 7 now becomes the argument. And now both of them are in base 10. Okay, now, if you, like I said, if you had a calculator where you couldn't change the base, I'm going to show you how this works. We'll go log, then we have 5, close that parenthesis, divided by, and then we will have log, and then we will have 7, close the parenthesis. Now, if I approximate, well, you know what, you will still see it on Desmos. So now, just to prove that this is correct, and they told us to round to 4 decimal places. There is a feature on Desmos that allows you to change the base. So if you go to function, if you go to log A and click log A, you notice here is down here where the base is. So we would type in 7 for the base, and then we will put in the argument, which would be 5. And if you notice, it gives us the exact same value. So the change of base formula actually works. And they ask us to round to 4 decimal places. So 9b, we have log base 6 of the square root of 15. So we will do log square root of 15 over log 6. So we'll do the log. Let's see, where's the square root? Square root of 15. So we'll close the parenthesis, divided by log 6. Okay, and then again we could test it. Oh, I didn't mean that. So we could test it. It'll be log. The base would be 6. Then what we will put in the parentheses would be the square root of 15. And it gives us the exact same answer. So rounded to 4 decimal places, it'll be 0.7557. Now what I'm going to do, I'm not going to keep typing this in the calculator. I'm just going to write it out in the change of base formula, but then in the calculator, I'm just going to do it using the base. So it'd be log of 47 over log 13. Then we could just put it in as log, it'll be base 13. And then it'll be 47. So it'll be 1.5011. And then we go to 9D. We have log base 5 of the cube root of 31. So this would be log cube root of 31 over log 5. All right. So we'll go here to this function, log, and then it'd be base 5, then parenthesis, the cube root of. Now, in Desmos, you can get the cube root by going here to functions, and you see here where it says nth root. Click that, and then you can hit the 3, and that's the third root of 31. Then you'll close that parenthesis, and your final answer here is 0.7112. And that is it. Now, if you have any other questions, feel free to contact me, and have a wonderful day.